So today's festivities do involve counterweight rigging, manual counterweight rigging in the theater. And here is a lovely drawing. And please ignore the stuff at the top. There are design load calculations, that we did, whatever this project was for. But I just wanted to remind everybody what a counterweight system looks like, or at least a bare bones counterweight system looks like. He said, making that as big as I can. Yeah, sorry, hang on, I gotta rearrange my screen here. Okay, so look, it's a counterweight system. This is a representation of a single purchase counterweight system. And by single purchase, I mean that whatever motion, whatever distance the batten moves, in this case, it would only go up because hopefully it can't go down anymore. But when the batten moves up, the counterweight arbor moves down the same amount of distance, so it's a 1-to-1 relationship. We'll talk about a double purchase system in a minute. So in a 1-to-1 relationship, whatever distance this moves, the arbor moves in the opposite direction, meaning that if you're going to build a theater and you're going to want to make sure that your pipes, your battens fly out high enough to get the scenery out of sight, which is the whole purpose basically of a counterweight system, and one that architects seem to forget on a regular basis. And even though this session is not about how to build a theater to make a counterweight system work and stuff, I will give you one piece of advice, that if you are your fly distance is the amount of distance that batten, excuse me, let me back up, the height of the stage house, to the loft blocks should be 2 times the height of the proscenium opening plus a minimum of 5 feet. So if you want your drops, your upstage drops and stuff to fly out all the way and get out of sight, that grid or the loft blocks, whatever the first thing that they encounter, the pipe will encounter, needs to be at least double the height of the proscenium plus 5 feet. If you get more than 5 feet, go for it. But usually it's a fight just to get that 5 feet. All right, so let's see here. Yeah, yet another drawing of a counterweight system, a little bit more up close and personal. And yes, they do have more than just 2 loft blocks and a dinky little pipe batten out there. You can have as many as you want, but I wanted to give you a pretty good representation of what a single purchase system looks like. Once again, questions in the chat, please. So here's a double purchase system. You'll note that the loft blocks are the same, head blocks the same. The human here is the same, relatively speaking. Although I think he's got a tablet in his hand. I'm not exactly sure what he's doing, but he's not supposed to be doing that while he's on the fly gallery there. But what happens with a double purchase system is somebody has screwed up and put something on this wall that restricts the travel distance. In a single purchase system, we need the whole travel, right? I need, if I want to travel 50 feet out here, I need 50 feet of travel over on the rigging wall side. I don't get that sometimes in a theater because an architect or some other unfortunate individual sticks a door here, the loading dock door, or the big fire doors, acoustical doors out to the shop or something. So they're here, and you can't run a counterweight system through them because then the doors don't work as doors. You can't get anything through. So what they came up with, whoever they was, I don't really know. They came up with a double purchase system, which looks suspiciously like a single purchase system with one difference. the lift lines going from the batten up to the loft blocks, over the head block, and back down to the arbor. In a single purchase system, they'd stop there. They would tie off to the top of the arbor. In a double purchase system, they do not. They go through that pulley and they go back up and tie off underneath the head block. So all the lift lines do that. The operating line, as you can see here, does the same thing. It's easier to show that going backwards. So we'll start at the head block. It comes down, goes through that pulley, back up to the head block, all the way down through the rope block, floor block, up to the arbor. And instead of tying off there, as you would in a single purchase system, it's got another pulley. So it brings it back down and it ties off to the floor. You can even see a little piece of it sticking down below the floor block there. I was very pleased to see that little detail show up in this particular drawing. So what happens here, when you move that counterweight arbor, you pull on the rope and you make that arbor go up, for example, the batten's going to go down, but it's going to go down at twice the distance that the arbor just moved, because you are moving this side and that side of wire rope. You're moving, in essence, 2 lengths of wire rope at the same time. So when this moves 1 foot, we're moving 2 feet of wire rope, so we're going to move that arbor 2 feet. Okay, that's the big difference between a single purchase and a double purchase system from a design standpoint. The arbor has a pulley on the top that is grooved to accept however many number of lift lines you've got, plus the operating line. And the floor block at the bottom of the arbor has a pulley that will accept the operating line and bring it back down here. So as an operator, when you're running a double purchase system, you are actually presented with 3 lines in front of you. Usually you just have 2, one here and one that goes up and ties off under here. Well, you've got 3 now, because it goes up and comes back down again. Typically, you operate on, I can't say that you have to do it this way, but most people will operate it. They will use the onstage line and the middle line to affect the counterweight arbor to make it go up and down. I said that this was this was the only real difference between a single purchase and a double purchase system from a design standpoint. The other big difference, which is huge if you happen to be on the loading bridge on that particular day, is that the penalty you pay for getting this advantage, this multi-speed advantage, is you have to double the weight in the arbor. So if you put 500 pounds out on the pipe, you're going to have to stick 1,000 pounds over there in the arbor. Yeah, if you're on tour and you're going into a double purchase house, you might want to stay on a bus that day. I don't know. I don't think you get to do that, actually. Okay, so that's the big difference. We're not going to get into a big discussion about double purchase because now you basically have it. Okay. All right, quick picture of a double purchase and a single purchase arbor. It's the difference between pulleys and holes. You get holes to tie off to on a single purchase. Double purchase, you get the pulleys top and bottom. Typically, a double purchase arbor is going to be at least half again as tall as a single purchase arbor. So if you had a single purchase system and you got a 10-foot tall arbor, then you're going to end up with a double purchase system, probably about a 15-foot arbor, because you just need the extra room to put all those counterweight in. All righty then, moving on. I just wanted to give you a couple of pictures. This is, and I think I showed this one time before, but this is without a doubt the cleanest grid that I have ever seen. My suspicion, it is brand new and nobody has actually done a show there yet. And I'm sure that the plywood is left over from the installers who were using it to land a stepladder so they could get up there and reach the building steel to attach the loft blocks. So what else can I share? Oh, we may get to it later on, but I want to point out that all these hangers that are used to support the grid, um, they're there. Um, they're there to hold up the grid, to help support the walking grid, and to get in the way. I mean, their job is kind of equal: hold up the grid and be an obstruction as much as possible. Um, I want to point out that this is not always the way that you get um, a theater built. What happens here is, it's in essence, it's an extra set of steel, because they have to either beef up the building steel to support not only the structure itself, but also the rigging weight, and then they put this more steel in down here. So you have to have a fair chunk of change to be able to do this. It's expensive. Typically, in my experience anyway, typically the loft blocks tend to end up on the grid in the loft block wells here, and going across, which makes it just that much more difficult to walk around. James, I'm not sure if this is jazzed or not. I don't think so. It's just too clean. Although if that is what I think it is, that might be a hammock over there. And if that's a hammock over there, then yeah, it probably would be jazz at Lincoln Center. Oh, another theater, just to give you an idea of what some of the stuff looks like overhead. This one appears, at least from what I can tell in this photograph, that it's not a terribly high theater, so that they chose to not put in a grid at all. There's just air up until you get to the building steel and the rigging on it, which means that once you put those loft blocks in, you can kiss them goodbye, because nobody's ever going to touch them again. Which is unfortunate. They do this a lot, whether or not you have a low building or not. They usually, when they can, they'll value engineer the grid right out of the design phase so that they don't have to pay for it, thereby making the technicians' lives in that theater as miserable as humanly possible. Hopefully you're catching on to the theme I've got going here. Oh, and we're back to this one again. I saw this when I looked at the program again this morning, and just reviewing stuff, and I saw this slide in here again, and I have no idea why I put it in there. So, but I left it in anyway. Okay, we're going to talk about operations first, and this is where I get to say it's a counterweight system. It's not terribly complicated or complex. And I should apologize to each one of you at various times, where I will now proceed to insult your intelligence by going over the mundane operation of a counterweight system. But it's a seminar on counterweight systems, so I don't have much choice. Excuse me for a second. Miserable. Matthew said miserable to the installers, to scaffolding. Oh yeah. Scaffolding to 60 or 70 feet is always a lot of fun. So, dealing with operations on a counterweight system, let's first start off with an assumption that you have an appropriately designed system, and that you have the pieces that you need. You have a grid, for example. You have a loading bridge. Most places have a loading bridge, but not all. I'm not sure how it happens, but I still see venues that are new or relatively new where they have taken the loading bridge out. And the only reason you take a loading bridge out of the design is to save money. And that really makes the lives miserable for the people who are running that theater. But we're going to assume that you got all that stuff first, and then we can circle back and look at how to deal with it when you don't. But gravity works in our favor here when you are loading in a show. Unless there are extenuating circumstances, the sequence of events is equipment on first and then the counterweight. And when you're taking the show out at the end of the run, it's the counterweight off first and then take off the equipment, right? Assuming that, number one, you have lowered the pipe or batten or bar, depending on which countries I have in attendance today. But you're lowering the batten into the floor so that you can attach lighting, scenery, audio, whatever. Snow bags for I've lost the name of the show. Never mind. Nutcracker. Thank you. It just, the name just absolutely disappeared. I could not find it in the Rolodex up there. But yeah, we're heading towards Nutcracker season, and as an aside here, many people are not going to get to do a Nutcracker this year, and for their first time in their life, they're going to miss it, and they're going to wish that they were doing a Nutcracker. Right. Starting at Thanksgiving, it's whining about Nutcracker season, and then usually right into December, it's whining about having to actually be on the crew for Nutcracker. Not this year. Anyway, batten in, scenery on, counterweight in the arbor, and then operate the line set, making sure that you have the right amount of counterweight on the in the arbor. And then at the end of the show, do it in reverse, and bring the scenery down, leave the lighting on the batten until the folks on the loading bridge clear the arbor and identify that they have cleared the arbor, and it's free to go. Okay. Excuse me, I'm sorry. Sorry about that. So, what's wrong with this picture? Say it again. I missed that. Can you tell? Somebody want to take a guess as what's wrong with this picture?
There's no one at the lock rail.
Line's not twitched.
Yeah. Well, you're right. There's no one at the lock rail. Somebody said that the line is not switched.
No twitch in the line. No.
Oh, the brake's off.
No, that's the brake is actually on. I saw that also.
Okay.
But this is the little index strip here that holds the little cards that tell you what's supposedly on the line set, except that nobody ever uses them or identifies anything properly. The rope lock itself is the heavier weight line right there. The biggest problem that they have that I see in this thing is that, excuse me, that they're doing this at the same time. Look, I'm going to mess with the lights. I'm going to put the weight in the arbor at the same time. I don't know how you do that. And, unless, no, I'm not even going to hazard a guess. I'm not even going to try and come up with a scenario. Somebody's going to lose in this situation. And typically, I bet you it's the deck folks who are going to lose here. You don't do this. And I've seen people do this, not regularly, but often enough to talk about it. It's just, I think they're trying to save the extra 27.5 seconds, or whatever it is, to get that particular job done just a little bit more quickly. And it doesn't make any sense at all. Please, when you're loading in, I don't know whether they're loading in or loading out, but whichever way it's going, one person works at a time, one in one location, and finishes that job before the people in the other location. All right. I mean, it just doesn't make any sense at all to me, anyway. Let's see. Right, and this speaks to that, and this speaks to what we need to maintain when we're running a load in or a load out, when we want to run it safely, you know, working in, let's establish, where we are here. I'm basing this on a, college, university, semi-professional theater, a professional theater, a roadhouse, for example, that has an experienced crew, both the local crew and the touring crew. They've been working together and they know how each other works, and they've developed a team, and I don't worry about that as much. Where I worry is in a high school, college level, as I say, semi-professional, regional kind of a theater where you have inexperienced crew, or some inexperienced, some inexperienced people are transitioning in and out of the crew on constantly, volunteers, all of that stuff. That's where people get hurt, and that's what we would like to try and avoid. When we did the fly rail session way back when, we touched on this a lot, and we're going to hear it again a little bit now. The good thing is, I think that things are becoming safer, and by reason of I'm not hearing about major accidents or fatalities. Haven't heard about a backstage fatality, and this is where everybody knocks on wood. But I haven't heard about one in a while now. Not a fatality anyway. There's been some accidents and stuff, but nothing that I know of that has caused a fatality. But this is where people need to understand what it is that that everybody's supposed to be doing. Okay. We need to follow these three things more than anything else. Communication is clear, and I think it's clear what that needs to be to a certain extent. Having one person in charge on the deck and having one person in charge on the loading bridge or the fly gallery, wherever the loading and unloading activities are taking place, even if it's on the deck. If you don't have a loading bridge, for example, you've got somebody as a deck chief who deals with the stuff that is on stage, and then there should be a chief that deals with the off stage, with the loading bridge, the fly gallery, or the deck. Right? People need to know their jobs, and people need to have somebody who's watching out for them, basically, is what we're asking for here. Hang on one second while I answer Mr. Borlas's question. Sometimes workers are asked to hang on to the pipe in the theater I work in. I think it was when the weights were coming off. Is this normal? Yes, it's normal. It has the potential to help, but it also has a potential for causing a significant problem. What it says to me is that whoever's running that operation is not really clear on the concept, or is taking steps that make it a little bit more unsafe. If, for example, we're hanging onto the pipe in the theater, let's assume that, okay, so the weights are coming off. So they've brought the pipe down. It's an electric. It's full of a bunch, full of Lecos or park hands or source force. I'm showing my age on purpose here. But it's full of lights. So it comes down to the deck. It's still in weight. So it shouldn't be able to go anywhere. And the next step is to start taking weight off of the arbor. If they are taking weight off of the arbor, then it's even less likely that the pipe is going to go anywhere, because they haven't removed any weight from down there. What I suspect happens is somebody is, there's a couple people on the loading bridge pulling the weight off, and there's a couple of people getting ahead of themselves and pulling lights off, because they're in a hurry. Right? Where this becomes a problem, where people holding on to the batten becomes a problem, is when they stop holding on to the batten, you know, because they figure, oh, everything's cool now, and they let go. So you got 5 people holding on to a batten, 4 people let go, not all at the same time, but one, you know, they kind of domino down. And you know, then there's only 1 person holding on to the batten, and it's not in balance, and they haven't taken enough weight off of the arbor. Those 4 people let go, the batten goes out, and the 5th person takes a ride. So I think you can see how that can be an issue. David, Jason, and Billy talk about soft goods. And we cover this, I think, in more detail on the fly rail situation. But yes, you know, you're going to hold on to the batten because the weight. All right, what they're referring to is you're going to strike a bunch of legs, for example. You know, so you got 2 legs on a pipe, you bring the pipe in, the legs pile up on the floor. You know, the weight of the legs is now on the floor, it's not on the batten. So somebody has to hold on to that until they pull the weights out of the arbor, and then they can take off the weight, take the legs off the pipe. Holding on to the batten in that situation, that's okay, that's a good idea. I like the Billy Larimore, he's talking about 500-pound tail downs. I really hope that you're talking about ropes that are rated for 500 pounds rather than having to drag 500 pounds around on a stage and attach them to the pipe, because that doesn't sound like any fun at all. All right, so yeah, we take different steps depending on the operation that we're doing, but in a normal, you know, wax on, wax off, scenery on, scenery off situation, lighting on or lighting off situation, it's going to be equipment on first, then counterweight, a counterweight off first, then equipment. Okay, Ashley, yeah, Ashley, it is only 2 stagehands worth of weight, but after lunch, that, you know, if it's after the lunch break, they're taking a nap, right? So operating a line set, let me point out that I'm just going to talk about operations. We are going to segue into the problems that you have with operating line sets, but I want to get through, you know, this kind of basic stuff first. This is an interesting one that people tend to mess up. And yeah, I'd like to see if anybody wants to, and we may have talked about this during the fly rail one. I don't remember, but does anybody want to hazard a guess as to what the weak link is in a single line set on a standard counterweight system?
Weak link.
The operator. Yeah, well, that's, I should have qualified that. I should have said the mechanical weak link, I suppose.
Off block.
Okay, those of you who have picked loft block, you win. I don't know what you win, but you win, because typically in a line set, the weak link will be the loft block, and this will be based on what kind of loft block it is, what material it was made out of, and frankly, what manufacturer built it, because some manufacturers have a higher tolerance to liability than others. So let's look at this and see if I did it right. I did. Can everybody see that okay? Just nod. No, don't nod. Pipe batten is rated for 30 pounds per linear foot. So if you've got a 1,500, listen to me, a 50-foot long pipe batten, you got 1,500 pounds worth of capacity. The lift line, which it's going to be 1/4 inch, 7 by 19 galvanized wire rope. On a 8-to-1 design factor, it has an 875-pound working load limit. And if you're old school like me, before the days of ANSI standards, it had a working load limit of 1,000 pounds. And the reason it had that was because the breaking strength of 1/4-inch wire rope, I don't care where it comes from, it is always 7,000 pounds. And it'll break right around 7,000 pounds, give or take a couple of pounds, literally just a couple. So in the old days, we gave it a 7-to-1 design factor because the math was really easy. Dividing 7 into 7,000 gave us 1,000. Well, those nice folks at the rigging working group decided that 8-to-1 was a more appropriate design factor. So lift lines now have a capacity of 875 pounds. Trim chains. The chain itself, the proof coil chain, the 1/4-inch proof coil chain, has a working load limit of 1,250 pounds. And I believe that's based on a 5-to-1 design factor. The 1/4-inch shackle is part of the trim chain, 1,000 pounds, again, 5-to-1. 5/16, 1,500 pounds. You know, some people go to a 5/16 shackle, where the wire rope is still the weakest link in that particular system. Now we get to the loft block. You know, we got a 500 to 750 to 1,000 pound working low limit, depending on manufacturer and depending on type of material the block is made from. 500 is cast iron, 750 and 1,000 is nylon. Okay, let me switch back over here to the chat and see what everybody's talking about. Michael Powers, you talk about you're talking about the Batten when you're assuming loft lines are on 10-foot centers. That's not exactly true, because you can have lift lines on different centers. I mean, typically the normal is 10 foot, but we're looking for the ability to place at least 30 pounds each foot on a batten. There's a way to tell whether whether or not you've overloaded your batten. I'll get to that in just a second.
Yeah, that's assuming roughly 10 foot.
Right.
To get the 30 pounds per linear.
Right. So here we go. We have a head block. Right now, head blocks are a bit challenging. Again, we're dealing with manufacturers, but we're also dealing with the size of the support structure that they're sitting on. And, you know, usually it's 2 I-beams spaced, 15, 18, 20 inches apart or something along those lines. That change, the working load of a head block will change based on that distance between the 2 head block beams. Each head block, you can safely assume, is rated for at least 2 times the individual line load. Each line, each lift line is rated at 500 pounds, say, for the loft, because the loft block's rated at 500 pounds. That head block will have a rating of at least 1,000 pounds times the number of lift lines it's got. So it's got 6 lift lines. The head block's going to be good for at least 6,000 pounds, right? And we'll come back to head blocks and loft blocks in just a second here. But I want to point out that the arbor, it doesn't have a rating per se. Basically, it's designed to hold as much weight as you can put in it in standard, normal built counterweight. So if a standard counterweight arbor, you can fill it and filling an arbor, depending on the height, let's just assume that we're gonna make this, actually that should be 6 inches, not 7 inches. I'm not sure why it ended up being 7, but an arbor capacity is going to be, if the arbor has 10-foot inside dimension, then it's a 9'6" of a usable space. You'll be able to use 9 feet 6 inches of it to get to, I'm sorry, I just lost my train of thought. You'll be able to use 9'6" to be able to fit a counterweight into the arbor. And that load rating at 14 pounds per vertical inch gives you a load rating of just under 1,600 pounds, 1,596, using a 6-inch dimension, not that 7-inch that I put on there. And I have no idea why I did. Maybe I was looking at a strange arbor at the time. So here's what I'm trying to impart with this whole thing here. There are lots of things that the components for all of the components except for one identify a load rating that is going to be, as individuals, is going to be relatively high. And when you combine them all together, like I said, 6 lift lines, I've got, let's just say I got 6 lift lines on a line set, and I have a 10-foot tall arbor, which means I've got, approximately 1,600 pounds worth of capacity. But even if I have the weakest loft block in existence at 500 pounds, with 6 lift lines, in theory, I've got a 3,000 pound capacity, except I don't, because I can't get more than 1,600 pounds inside the arbor. So it's kind of self-limiting in a way. The arbor is going to dictate to you how much weight you're going to be able to put on that line set, because you can only get 1,600 pounds. And no, you're not allowed to hang a bunch of sandbags and stuff off the outside of the arbor, okay? Or, as I've seen, the metal canisters with lead shot in them. It's like, a 2-foot long tube, a cylindrical tube that is full of lead shot, weighs an extra 50 or 60 pounds, hanging off the side of an arbor. And I pointed out to them when I was doing the inspection that the tube hung down so far that when you brought the arbor down to the floor, the tube hit the floor first and would tip over and spill out the lead shot. And then when you spill out the lead shot, you're no longer in weight, and you now have a runaway with the arbor taking off, heading up. So, and they hadn't thought of that part, but I got them to think about that part. So we're self-limiting in the arbor height, which is not to say that you can't overload a loft block. I know theater and scenery is supposed to be light and portable, but I think that that concept went out of existence a few years ago. And people are hanging incredibly heavy things that you would not normally expect to find in a counterweight system. And if they are point loading a loft block, if you've got a loft block that weighs 750 pounds, that has a rating for 750 pounds, and you go ahead and hang 1,000 pounds underneath it, thinking that the whole line, that's all you did is put 1,000 pounds on it, and the arbor will take 1,600, so you're good to go. No, you're not. You're gonna you run the risk of doing damage to the loft block. And don't talk to me about the design factor. We're not going to go there, because you're not supposed to be including design factor into your equation here. You're supposed to be working with working load limits only, or in the case of several of the rigging manufacturers, they do, instead of doing a WLL, working load limit, they do an RWL, which is a recommended working load. And, I'm sure that their lawyers had a reason for doing that. I don't know what they are. I'm going to backtrack for a minute in the chat, because Tom Pigeon, and hopefully I'm pronouncing that properly, Tom, has a good comment here. I've been talking about systems that are relatively new. Not everybody has a relatively new system. And, you know, Tom's got one that's 50 years old. Sad to say, Tom, but you've got your money's worth out of it. And at this stage of the game, you have a system that more than likely, you know, it's suffering from, you know, a lot of wear and tear, but it also doesn't meet current ANSI standards. So when an inspector comes in, if they know what they're doing, they should be pointing out to you, you know, the deficiencies in the system, that, you know, this component doesn't work right, this is broken, you know, this loft block is bent, or, you know, whatever the individual problems are. But they should also be pointing out to you that the loft blocks at 50 years old, it's entirely possible and likely that the loft blocks do not have bearings, that they have bushings, and they don't meet current standards. The material used to mount the loft blocks to the grid will be cast iron, and that does not meet current industry standards. The wire rope clips will be malleable, and that doesn't meet current standards. So Tyler's right in suggesting that you have an outside inspection, you know, somebody come in and do an inspection for you. But hold on to your hats, be prepared for what you're going to find out. Okay. I'm just reading Kana's note here, and okay, so you got that squared away. When, you know, our terminology is up to speed. James Lyle has mentioned about marrying two arbors together. You can do that, but, you know, you want to make sure that it's a good marriage. Well, we all do, right? The problem that you have, and the problem that I have seen, is that when they marry the two arbors together, and what we're talking about, folks, is you got too much weight on the pipe to fit into one arbor. So you want to use its next door neighbor as an assistant. And you want to be able to pile weight into the next door arbor, and raise them both up and down at the same time. If you don't make sure that the arbors are married together in a rigid manner, and the pipes are married together also in a rigid manner, well, actually, you don't have to worry about the battens so much, but the arbors have to stay in the same relationship. Otherwise, if one starts to move, then you run the risk of transferring weight from one side to the other and overloading one side or the other. I've seen it happen where it's transferred, you know, one arbor got higher than the other one because it hadn't married them together properly, and all the weight kind of shifted over to the one batten, you know, the upstage batten, and it overloaded the batten, and it caused a runaway. You don't want to do that. Going through the chat some more. Hopefully that answered your question. If not, James, let me know. Michael Powers, would you just give me a break? No. Yeah, we're going to get to the front loading arbors in just a minute. Yeah, and Cindy, you're right. Yeah, I mean, if that tube had tipped over and the lead shot had come out, it would have been a Looney Tunes cartoon for a long time. What about attaching a chain hoist to the bottom of the arbor? And this is Robin's question. Yeah, you can attach a chain hoist or any other mechanical device, some mechanical assist device, a block and tackle, for example, or a capstan winch. Any of those devices will work, provided that, number one, you've attached it properly to the bottom of the arbor, right? and that the bottom of the arbor will carry that kind of extra pull on it. Now, in newer arbors, it's not a problem. But if we go back to Tom's theater, sorry, Tom, I'm going to pick on you now. But, you know, we go back to his theater, his arbors, the bottoms of them more than likely are either cast iron or malleable iron. And they're a piece of flat stock that's, yeah, maybe 5/8 of an inch thick. And there's an eye bolt sticking out the bottom of it. And that eye bolt is there to attach the rope to, the operating rope. So, you know, you're not seeing a whole lot of force or a whole lot of weight being applied to that eye bolt. But now you go and attach a chain hoist to it, and you start yanking on the arbor with that chain hoist, you run the risk of either snapping the eye bolt, or more than likely snapping the bottom plate right around the eye bolt. Okay, so it presents a problem. The other side of that equation is, what are you attaching it to on the floor? You have to make sure that you're not going to pull your floor up. You know, people will attach it to the locking rail, but if that locking rail has been lag screwed into the top layer of the stage floor and that's it, you now have a locking rail 5 feet in the air. Cindy is asking, marry at the arbor or at the pipe? You marry at the arbor. Billy, you crisscross the pipe end picks. Okay, so you're taking the lift, if I understand you correctly, you're taking the lift lines from the ends, on the ends of the battens. Let's say you're using battens 5 and 6, and you're just swapping the long and the short lines, and, you know, switching 5 over to 6 and 6 over to 5. Is that my understanding? Do I have that right? Okay. That will certainly help. It will help keep the battens, you know, relatively together, but you still got to marry those arbors together really well so that they do not move independently. The key, that is the key. All right. Let's see, where was I? So we were making sure that you don't overload your individual components of a system, i.e. the loft block. Don't allow the thought to be, well, you know, I can fit the weight in the arbor, so it's got to be fine no matter where I put it along the batten. That's not necessarily true, because you could overload the batten. You could stick 1,000 pounds in between lift lines, and then share the load on those two loft blocks, right? But if those lift lines are 12 feet apart, you run the risk of bending the batten. And this is probably a good time to just interject how to tell whether you have damaged your batten or not. The first indication that you've damaged the batten is you've bent it, and where it's bent, it's now touching the floor, and the rest of the batten is 4 feet off the deck. That's usually a pretty good indication that you've done something wrong. But for a more subtle situation, there is a formula that engineers use to determine the appropriate amount of deflection. And that formula is 1/180. So what you would do in a theatrical situation with a batten is you would take the distance between two lift lines. Now let's assume that it's a 10-foot span, goes from one lift line to the next. You convert that 10 feet to inches. Sorry, Canna, we're working in Imperial here. What can I tell you? But so we're at 100. We're now at 120 inches divided by 180, and that fraction will translate into the amount of deflection in inches that you're allowed. So if that formula tells you that you're allowed to have, you know, a 1-inch deflection, and you go out and measure your smiley face, as Tyler says, If you go out and measure that and you have 2 inches of deflection, you've overloaded the batten. So, you know, it's not easy to do, but you know, people do tend to work at it, and occasionally they will bend a batten, you know, with a load on it. You know, 1/180 is the formula to use. Typically, however, people bend battens by they run it out without paying attention, and they run it into something else, and they keep pulling. You know, it'll hit a piece of scenery, it'll get caught up on an orchestra shell ceiling piece or something, and it gets stuck, and they keep pulling, and it doesn't take much to bend it once you're doing that. Okay, I wanted to show you a typical trim chain, which is in North America the most common way that we terminate wire rope to the batten. Whether or not a trim chain is actually needed or required is not really the discussion, because we could do that all day. But this trim chain meets industry specification, industry specs and ANSI standards. And it has, and this is the hardest thing that people seem to have, this is the thing that people seem to have most trouble with, is it has a dual load path. Yeah. Both ends of the chain end up in the thimbled eye. One of them is on a shackle. The other end has been captured in the thimbled eye when they built the lift line itself. That dual load path is the key. Remember, we're using 1/4 inch proof coil chain, has a working load limit of 1,250 pounds. In this, in this drawing, each leg of that trim chain has a working load limit of 1,250 pounds. So you've got, you know, you got 2,500 pounds worth of working load limit in this application here, which is only what, 800 pounds, 700 pounds more than the arbor will carry. The shackle's got a load limit of, I think it was 1,000 pounds, we said. And the wire rope's got an 875 pound with the compression sleeve. It's got 100% efficiency rating. So I'm at 875 pounds there. Okay, that's what a typical connection, again, here in North America should look like. This one, I put this one in here because I betcha my European friends have seen this more often. Over here, we call these, I've heard them called opera clamps. So this replaces a, this replaces the trim chain. And the idea here is if you need to trim this line set, you would loosen this batten clamp and move it in a little bit. So it would raise or lower depending on which way you went. The batten. It's okay. I don't, you know, I'm not a big fan of them because there's a lot more hardware there. And, you know, even though I wouldn't mind selling you the hardware, installing it's a royal pain. All right, going back over to the chat here for a minute. Matthew Thomas says he's got dual pipe battens. Yeah, you've created basically a flat truss with 2 pipes and some connectors of some design to, and that does indeed compensate for the a span that's too great. You can only get so far with that. On a single pipe batten, the longest we've found that makes any sense, and it's at the very edge of acceptable, is 12 feet. We really do want to see 12 feet will work. But you know, you're gonna have to think about it every time you put something on there. With a dual pipe batten, a ladder batten, if you will, you can get up to about 15 feet. And now it's not a question of load capacity, it's a question of stability. Over 15, past 15 feet, the ladder batten will tend to roll out there in the middle, and that doesn't help you. Steve Litterist asks, if I'm replacing a trim chain, do I terminate the 2 shackles in the eye or both ends to the same shackle in the eye? look to your load ratings. You know, ideally the eye has captured the end link of the chain, but I think what you're referring to is you're just taking, you're cutting out the old trim chain because it was something less than acceptable. And now you have a piece of chain you want to get connected there. Two shackles is certainly acceptable, or I would go up to a larger diameter shackle. I would get the best that I could fit into that shackle. A 5/16 shackle will fit into the two end links of the chain, and then you can go pin up to the thimbled eye. Hopefully that answers the question. Scott Oliver allows higher out trim. Yes, it does. It does. The opera clamp or the Met clamp does allow for a higher out trim by probably about 9 or 10 inches at least. So, you know, if that's what you need, that's the way to go. Cindy asked, trim chains versus batten clamps. It depends on the situation. Trim chains give you the ability to trim your batten. Batten clamps do not in and of themselves. Murphy's Law says that if you use trim chains, you'll never have to trim your batten. And if you use batten clamps, at some point, you will. Sadly, people will use batten clamps and put a turnbuckle on them. And there's nothing in a theater hardware lexicon that I hate more than turnbuckles. And I don't think that they have any business being backstage at all. So I wouldn't use them. You know, we've done installations where we've used just a batten clamp and we've gone with a shackle directly to the clamp itself. And we just have to be really, really careful when we do the installation that we get it right. What is a pain in the ass? They get in the way of the lighting and rigging clamps. Oh, the opera clamps, yes. Okay. So I'm running through there. Camille, your system has a mix of both. Are you talking about the trim chains and batten clamps, or trim chains is something else? Frankly, I forget.
What do you want? You've been out for a walk.
Somebody, oh, that was Matthew. You're talking to your dog, Matthew, I can tell. Turn the microphone off. Scott asked, what is the derating for 90-degree load on batten clamp? Oh, so you're talking about the side pull on the batten clamp. That is an excellent question, and I don't think there's a manufacturer in the country that will give you that rating. That batten clamp has a rating of 750 pounds based on, all right, let's back up, depending on manufacturer, but it's going to be 750 to 850 pounds. And that's in a straight pull-to-pull application. Typically, when you side load something like this, you know, a piece of hardware, a shackle, an oval ring, you know, a pair ring, for example, any of that stuff, you reduce the capacity by 50%. So I don't know if that's what's going on here or not. I don't have much experience with this stuff, but now that you have broached that question, I'm going to find out. I just won't be able to do it during this class. Okay. Right, James is the last one on the chat, and then I want to move on here because we are a little short on time. You worked at some theaters that have the wire rope going right to the batten with a clove hitch and 2 Crosbys. That was the standard way of doing it right up until the 1970s. Everybody did it that way because that's what they knew to do. And, you know, from the 1920s, all the way up into the 1970s, into the 1980s. I mean, I'll tell you a quick story, and I mean no disrespect to the local one guys at all. But I did the original installation of the Marriott Marquis Theater in Times Square. You know, it was under construction. We went in, we did the rigging installation, and we're, you know, pretty much the last contractor in there before the building gets turned over. And, you know, the building was late, of course, and they had scheduled a show. So the stagehands were checking in every day. Can we get in? Can we get in? We want to get in and take care of, you know, loading in the show. We hung the battens, and we hung them on trim chain because this was in 1985. And we hung it on trim chain because that's what was specified. And it was still new. And the stagehands were used to clove hitches and a wire rope clip on top of the clove hitch. And so they changed it. And we went, no, why did you do that? You lose capacity. You do lose capacity. A trim chain clearly has the chain itself has a higher load capacity than the wire rope. And when you tie a knot in a wire rope, you're going to lose a significant amount of capacity. So yeah, don't do that. Don't do that. All right, I'm going to move on here for a second here to, again, with this drawing, it showed up again. Operations, we've done that. We've done that. Oh, did I duplicate everything? Yeah, I duplicated, folks. Oh, okay, here we are. A quick conversation about rope. The standard operating rope in a counterweight system, and by standard, and I have no empirical knowledge of this, but I'm betting that 75 to 80% of the theaters in this country use multi-line 2, or some other manufacturer's version of multi-line 2, which is a 3-strand twisted synthetic line. It was the most obvious choice when we started switching from manila to a synthetic, because it looks the same, and you can do things with it that you could do with manila. You could open it up, you untwist it so that you could run a trim mark through it. You know, so it was the expected thing and the most common, and there's really no reason not to use it. There's nothing wrong with it. It does just fine. There is one very minor drawback. It is not 100% polyester. There is a filler material that they use. The orange tracers are made of polyolefin, and there is some other polyolefin in the assembly. It's a very inexpensive material that they use to make a larger diameter and have it not be too expensive. You know, if they made it 100% polyester, it would cost you an extra, you know, what, 20, 30 cents a foot or something like that. So they put polyolefin in there. It reduces the working load limit on the line. The working load limit, I had to go check because I forgot here. Yeah, the working load limit on 3/4 inch is 2,000 pounds. So you're going to be hard pressed to mess with that. That's not a challenge, okay? So that's the most common. And yes, it takes trim marks best, because the right way to do a trim mark is to untwist the bundles so that you can run a piece of, you know, ribbon or cloth tape in between the bundles and have it capture it that way, not wrapping electrical tape around the line. Not only does that tend to move every once in a while because it gets caught up in the rope lock, but it makes things really icky after a while. It gets the line gets sticky and gross. Stage set X is the other line that you will see in, or again, a variation on that. These two are made by the same company. Stage set X is a double construction rope. It is a braided polyester shell, which you can see here. And if I had half a brain, I would have put the section view on there, but sorry, I didn't. But the interior is polyester filament, just the fiber laid in a line and wrapped in polyester ribbon just to hold its shape. It's a good line in terms of the fact that there's very little stretch because the load bearing component, the core, is just, filament laid in a line. So there's no stretching. Polyester, this kind of polyester anyway, does not stretch the way this line will stretch. The shell will stretch because it's braided, and the braiding will rotate when you put weight on it. So it'll kind of twist in the direction of the pull. It's an okay line. It's got a higher load rating than the multi-line 2 does. He said forgetting completely. And I'm sorry, I told you that the multi-line was 2,000. I lied. It's the stage set is at 2,000. I had my chat is in the way here. Where am I? I'm at 1,900 pounds. So it was just a little white lie. It wasn't a big one. 1,900 for the 3/4, 2,000 for the stage set X. The big problem with this line is trimming. The cover is not attached to the core. The shell is not attached to the core. So when you wrap electrical tape around here, it will, eventually it will stretch. You'll pull on that rope and the shell will move just a little bit before the core does. And that will slowly tend to move the shell along the rope. The rope industry has a name for it. They call it milking. So you can get that image. So that means that your trim marks aren't going to stay put. And you can't really open up this to put a trim mark through it because, you can stab something through there. But when you stab through it to get into the core, you're going to damage the core with whatever device it is that you're using to stab it. So, over the years, this was, a little bit more common 15, 20 years ago. People have headed over to the multi-line in waves ever since. Show braid is a double braided rope. So it's got a braided core and a braided shell. Remember that this is a braided shell, but it's a single line filament core. This is a really nice, soft, flexible rope, which has no business being in an operating line whatsoever. The core and the shell will milk, and they'll do it easier than on the Stage Set X. We learned the hard way many years ago at the Palladium nightclub, and we never went back to it. And over here, there's multi-line, Manila for you purists of the world, but we don't have to talk about that unless you really need to. So we've done that. Look, head blocks. Just want you to see what it looks like. And we're heading into the don't do this kind of thing now. This is where you can run into some trouble. Can't believe I'm running long. I'm running out of time here. Loft blocks. This is an upright loft block. Sits on the grid. This particular loft block made by this particular manufacturer, you can turn it upside down and hang it from the building steel overhead. It's designed as what they call a universal orientation. This is only to be hung underneath a beam. You hang it from the bottom flange of the beam. So those are loft blocks. What do I got next here? I got another arbor. We've seen enough of arbors today to last a lifetime. There you are, Michael. There's your front loading arbor. This is a relatively new design, a few years old. It is, I'm starting to see it in some theaters. I don't know that it's taking the world by storm, but I don't know that there's anything except for one thing that's taking the world by storm, but we're not going to talk about that today. But it's a front loading arbor so that you don't have to worry about, you can use the full height of the arbor because you got these little doors, you stack the weights in, close the doors, latch them down, and you're good to go. It's a nice design. T-track, well, this is a J-track. You know those guide tracks that the arbors ride in? This is what the aluminum version looks like. And, this would handle 2 arbors, one on each side. The guide chutes would wrap around this flange, this side of the flange from one arbor, and the arbor next to it would ride on this side. Okay. So you can see that there's not a whole lot of distance between the two arbors. This is typically about 1.5 inches. So the arbors are very close together. I mean, we don't have a lot of real estate backstage, and we don't want to give it up. We don't want to give up any more than we have to. So this speaks to making sure that you keep an eye on your arbors, that the guide shoes have not loosened up, so that the arbors are not flapping in the breeze and not swinging back and forth, because with that little bit of a gap there, you're only going to get maybe 1/2 inch or so. They could hit each other, and if they hit each other, and Murphy's law comes into play, as he always does, they could pick up an arbor out of one of the a weight out of one of the arbors and knock it down to the floor, which would not be a good thing. This is a more traditional T-bar. I couldn't find a section drawing, for some reason. I don't know why, but it's in the shape of a T. This one is called a J guide because look, it's a J. This one is in a T with the flat face on the onstage side. An arbor would ride here, another one here, and another one here. It's just a different shape T, a different shape guide. One of the things I want to point out about guide tracks that you may have experienced running a show or running a line set is you'll be pulling on that line set, and you'll reach a point in the travel where it's hard to pull, and you got to do some extra oomping to get it over that hard section, and then it keeps going again. People, just they don't know really what to look for or why that's happened. What's creating that problem. It's a misalignment of the attachment right along here. The T guide bolts to this bar in the back, and that happens every 5 feet going up the wall. And if you got a 60-foot wall, you got 13 of these things. Sometimes the T-bar in the guide track, in the attachment bar, is misaligned, and it'll be off by 1/8 of an inch. And the 1/8 of an inch is enough to create friction as it goes through that particular section of track. So if you have that problem, you got to go look at your track. It's not the guide shoe's fault. It's not the arbor's fault. It's almost always the T-bar, and it's almost always from an improper installation. The other thing you'll get, these T-bars come in 20-foot lengths, so they have a seam every 20 feet. And most of you pull on a line set and it's going up, and you hear a thump, and then you hear another thump, a second or two later. And what that is, the guide shoes rubbing over a misaligned joint right here where the next T comes in and meets it. It's not a big, excuse me. It's not as a big deal, except that it wears away a little piece of the material on the guide shoe, and you do it often enough, that guide shoe now has a bigger gap in it, which will allow the arbor to swing from side to side more. And when it gets enough swing, it hits the arbor next to it and pulls a weight out, drops it down to the floor, and everybody's unhappy. So, when you have situations like that, either the arbor is hard to pull, or you're hearing what basically is kind of a rhythmic noise that happens at the same place all the time, then you're checking the splice joint and align them properly to take out the problem. It's not a question of just pulling on it further or pulling on it harder. Yeah. What did Michael? The width of the guide shoe determines arbor C to C. It's actually the T-bar that determines the guide shoes. The T-bar was designed first, Michael, and then you build the guide shoes to the T-bar. I wanted to point out this particular drawing. This photo has always been one of my favorites. The loft blocks have been put on backward. The lift line's going down to the batten and over to the arbor. This is the load-bearing component of the loft block. You can tell there's all that metal there, right? And all they have is this rod going in and clipping around, hooking around the bottom flange of the I-beam. That rod is there to keep the arbor from flapping back and forth, or upstage, downstage, if you will. Well, somebody made a boo-boo here and they put it on backward, put all the load on that hook. And in some cases, in this particular theater, they had dedicated electric, so the lighting was always on the same battens. And, you know, lighting's heavier, and it started to bend the hooks out. And fortunately, we saw it before it manifested itself elsewhere. Now we're into don't do this kind of stuff. This is a problem that I'm beginning to see more and more as Unistrut becomes more and more popular backstage, which period it, period should, period not, period be. I just thought of that and it came out probably too long, but you should never use Unistrut backstage. In this particular application, they've bolted a multi-line block. There's a lot of force happening on that block. You can't see it in the photo, I don't think. Yeah, it's just out of the frame. But there is one line that is dropping down. It's the short line going down the batten. The other 5 or 6 are going over to the head block. But I now have Unistrut nuts clamping around the bottom of the Unistrut track, and the pull is in line with the track, which means that only, you know, how tight you made that, you tightened up that bolt is going to determine whether or not this loft block doesn't slide down the track. A piece of steel with, you know, regular steel, I-beam, whatever, with, you know, a clamp or a bolt in the appropriate orientation, this is a really bad idea. Hopefully you can see why. Okay. Here's another problem. Well, there's 2 problems here. I got a twofer on this one. It's a loft block. It is the short line loft block, and I can tell that because there's the end of the batten down there, and the line is running to the right, going off to the head block. And you'll note, number one, that the fleet angle on the block is off enough so that the wire rope is rubbing up against the side wall of the sheave groove, and that's not a good thing, especially with the newer material, the nylon that we use for the sheave material now. It's no longer cast iron, it's not steel, it's nylon, and so it's plastic. And the old cast sheaves, you know, they would wear away, but they would deal with this kind of a fleet angle problem better, because they wouldn't break, they wouldn't fail, they would just kind of wear out over time, and it took a long time. The problem with the nylon is when you have that kind of side pressure pushing up against the side of the groove, the nylon does not wear away, it simply snaps off. So you'll break away a whole section of the loft block, the wire rope will jump out of the groove and get down in between the side plate and the groove, the sheave itself, and it will jam there. And it will only do that when you have a fast cue to make and you're trying to get a piece of scenery up and out of sight, and so that they can go into the next show. And that's the only time that it'll happen. So be prepared for that. All right. Yeah, you want to make sure that the fleet angle is appropriate. You should be able, you don't need to sit there with a measuring device of any kind. Protractor was the word I was looking for. You know, you just look at it. I mean, you can see over here that the wire rope is seated reasonably well in the groove. I've got the same amount of gap on both sides, and then I start to lose it here. Well, if this sheave was kicked over a couple of inches, it would be fine, right? You can see that. It's easy to see as long as you got some decent light. The reason that it didn't stay that way is they never bothered to bolt the offstage side of the loft block. It's like, what's up with that? Yeah, there's not a whole lot of weight on that side, but you want to keep it from, you know, running up and down stage and doing exactly what it did. All right, going back to the chat here real quick. I saw a couple. Is it SOP to not bolt down the other side? No, that is not. They should have done that. And that's exactly what happened. Somebody walked over and accidentally kicked it, and over it went. Here's another one that, you know, presents some problems. Now, this particular environment is not that big a deal, but I've seen it, but this is the photograph I've had. All these loft blocks are held down by J bolts, and the J bolts are down into the subway grating. And, you know, a J bolt is an unrated piece of equipment. Somebody in a factory somewhere lopped off the head of a hex bolt and then bent the shank. And look, now we have a J bolt, and they use that to grab the loft block. It's perfectly acceptable in my world to stick a J bolt in here and here, because all you're doing is keeping this block from moving up and down. There's no load on it at all. It's being taken up by these guys over here. The fact that they have J bolts, I think they have, well, you know, it's a little hard to tell, but they may have J bolts in here. That photograph is a little, I'm hoping it's misleading, because if it's what it looks like, then the hex nut hasn't engaged the bolt by very much. But for our purposes, yeah, I would put a J bolt on both of these to keep it from flapping in the breeze, but not as they have done by putting J bolts on the load bearing side also. So now everybody's load bearing, because these guys are going to roll over a little bit. The load's going to pull a little bit. You know, everybody's going to tilt off stage, and then the loft block moves, and the rope that's coming down and trying to get in between the gap and the subway grating is now going to be rubbing hard up against the plate on that subway grating, and that's a problem. And here's one of the more common problems that we see that gets by almost everybody. You're looking at the head block. You're standing on stage looking at the head block, and the lines are coming in and running down behind the block. Now, I would have liked to have shown you a picture of the other side, but there's never any room to get onto the other side. So what this photo I'm going to use this for is this spacer bar does double duty. It holds the block together, the side plates together, and it's placed so that it's up against or very close to the sheave itself, so that the cable and the rope can't jump out of a groove. There's not enough of a gap. So getting the wire rope and the operating line in here, in between this bar and the sheave, is not an easy process. And, you know, so you're doing it on both sides with the operating line, but only on the back side with the wire rope. And many times they miss. And instead of the wire rope coming down in between the bar and the sheave, it runs over the bar. You know, because they're reaching over, they can't see, they're doing it by touch, by feel, and they miss on occasion. You will know that that has happened when you start operating a set. Let's say that it's happened on this line set here, and one of the lift lines has wrapped itself over the spreader bar on the back side, but this one is fine. So you're operating this one and it runs fine, everything's cool, you do your thing, and then you go to run this one, and you almost hear it, but you certainly feel a rhythmic thumping in kind of a noise coming through the line. Not that sharp, obviously, but it would be rhythmic and would pick up speed as you picked up speed in running the set. And what it's telling you is that, you know, somebody has wrapped either a lift line or the operating line over the spreader bar in the back, and you need to go and look at that, because it'll chew up the operating line. If the operating line is over it, yeah, you'll beat that up and you'll have to replace that pretty quickly. If it's the wire rope, it'll chew up the spreader bar, and it'll take longer, but it'll eventually cut through the spreader bar, and the tube the little piece of pipe that's in there will get cut in half and will fall to the ground. And from 70 feet, that's not a good thing. Huh, okay, how are we doing here? We're pretty much out of time. Let me just look at the chat here. I got just a couple of things, so if you can hang around, that'd be cool. What should we use instead of J-bolts for spot blocks? I would use, some kind of a formed clip that has regular bolts, so that you're not relying on a a grade 2 soft bolt. I would use, take a piece of either angle iron or even a piece of flat stock, and instead of running a J bolt through the base angle, that one, nope. Instead of running a J bolt, an individual J bolt that's hooking onto the flat stock, I would the grading, I would run a standard grade 5 hex bolt down there and have a single piece of either angle iron or flat stock on the underneath side and bolt into that. It's a royal pain in the butt to get up under there to do that, but it's easier. I mean, it's safer, not easier, it's safer. However, Cindy, you said what we should use instead of J bolts for spot blocks. Stop and look at what you're doing. For the photograph for this, is this the one? Yeah. We got J bolts on all of these, but I'm looking at them, they're all running with rope. I know that it's a standard counterweight system. So that tells me that all of these rope lines here are spot blocks, typically for cable picks. You're picking up the power feed off the lighting battens, right? So a J bolt in this application is not a problem. It's only when, and I guess I didn't make that clear, it's only when, sorry. It's only when I mean, I'm on a lift line here because I got the wire rope running down there. So, and with the orientation to the battens that I can see other battens, I'm going to have more load on here, and I'm more concerned about it on this block than I would be on that one. Does that help? You said thanks. Good. Okay. I want to move on here. There was a couple of other things. Oh, didn't want to get there. Oh, we'll get to that last one in a minute. This is for all of you who have older theaters or you don't know the load ratings on your loading bridge. Especially in older theaters, this is an extremely dangerous condition. What they have done, and I understand the thinking behind it. We want to be able to walk. The arbors are over here on the right, so we want to be able to walk and load. We could turn around, pick up a weight, stick it in. It's nice and easy. When they designed the loading bridge and they determined the load capacity of that loading bridge, they used both I-beams. There's an I-beam running the full length of the bridge on the offstage side, and there's another one on the onstage side. And they determined the load rating of that bridge by both beams. This stacking the counterweight in this manner puts almost all of the weight on a single beam. There's nothing or very, very little that's transferred over to this I-beam. And that creates a problem. I have never seen a bridge come down, but in some older theaters, I have seen bridges that wanted to, that they were starting to deflect significantly. And, that's not a good thing. So if at the very least, check with your engineering people if you've got them, or if you've got some paperwork or something, and find out what the per square foot load rating of your bridge is, and keep it, stick to it. There's nothing that says you can't put counterweight all on this side, put an even deck all the way around. You're allowed to walk on counterweight. It won't hurt you, Well, put knee pads on or put carpet on top of it or something. I know kneeling on counterweight isn't any fun. But make sure that you're loading your bridge properly, especially if your theater, as apparently this one does, your theater goes dark and they strip out everything. and they get all the weight on the bridge. Now you got all the weight on the bridge, and you want to know whether or not you can continue to do that. Okay, let me see what they say. Bye, Judith. The offstage kick plate does not give much room for safe stacking. Yeah, okay. Jacob said that. You're right, but you got to stick to whatever that is. That looks to be about a 4-inch kick plate. OSHA only requires a 4-inch kick plate on working catwalks. They don't know what we do, so they don't know to say 4 inches everywhere except in theaters where it should be 6 or 8 inches. So you got to pay attention to it. See you, Dennis. So that about finishes it up for me. I do want to point out, why is this not switching over? I do want to point out that today here in the States is Veterans Day. This is in the UK, it is Memorial Day, or Remembrance Day, excuse me. And if you don't know the significance of poppies, these are all red poppies at the Tower of London. If you don't know the significance, I suggest you look it up. I think it's important. You want to Google poppies and Flanders Field, Flanders. But it is Veterans Day, and I think we all, regardless of how we feel about armed conflict and all of that, I think our veterans deserve our respect and our thanks. And I think, as pretty much any veteran will tell you, they also would hope that we can find a way to get along without having to need veterans and armed conflict in the future. And that, my friends, is it for me for the day. We will be back. We will be back next Wednesday, and we will talk about what are we talking about next? Motorized systems. I'm also probably going to throw in fire curtains in that one, because I think the motorized won't take up the whole thing. But thank you all, and I hope to see you and your friends and family next week. Have a good rest of the week and a good weekend.
Hello.
Is that somebody saying hello?
Yeah, it's Mike DeRosa. I got a quick question about the inspection criteria for fly systems based on this class and the ANSI standards class we went over.
Right.
It says for the inspector, 5 years or 10,000 hours of inspection, design. So, and it specifically states operation is not acceptable experience for the inspector, right?
Well, so I don't have a good answer for you to this one. That standard does indeed say that. I don't agree with the standard. As I mentioned, I think I mentioned during the ANSI class the last time, I only get one vote, and that standard had and has some serious, what I believe to be serious flaws in it. And, I was overruled. I wasn't the only one that felt that way, but the majority of people on the group felt that the standard was appropriate as written. And so that's what was voted in. Yeah, 10,000 hours is is a lot. You need a lot of experience, but 10,000 hours is more than a little extreme. Does that help any? Did I lose you, Michael?
We're trying to come up with a plan for our theaters inspections coming up in the near future, because we've been doing them in-house.
Yeah.
We're trying to make sure that now that we've seen the standard, like, are we doing that right, or do we need to specify with the IA to have a specific number of hours, or do we have to go to a outside contractor? So we're trying to get a little bit more clarification. And if you've got time for an offline call later this week, I would love to pick it up.
I have the time. What I will tell you online, I don't know how many people are left in the room, but if, you know, it may benefit them also. Why don't I know how many people are left in the room? Where's my toolbar has gone away. Anyway, the criteria that you need to use first and foremost for an inspection is that they need to be done annually, and they need to be done by a qualified person. That standard identifies a qualified person in a manner that I think is challenging at best to meet. And thank you, Inger. You know, I don't think you need, you're not going to find a lot of people who meet that criteria, right? How many years is 10,000 hours if you do it 40 hours a week for all 52 weeks? I mean, you're still.
It's based on 40 hours a week for 50 weeks a year with 2 weeks vacation. It's like what contractors use, you know?
Right.
That's where the 10,000 hours comes from in 5 years. I agree.
Right.
It's kind of hard to find people that are truly qualified, and that does little to help us determine.
Well, I'm going to take off my seminar hat for a moment and put my business owner hat on. We're the leading inspection company in North America, and we meet the criteria because, you know, my guys have lots of experience, which is not to say that there aren't other people out there who also have that amount of experience. It's just there's not that many of them. And you know, it was an arbitrary number, I think, that I don't think you know, I felt was onerous. Michael Powers, you're saying, what is the criteria? What do you mean?
What is the criteria for, quote, being a qualified person? Where is that listed?
A qualified person. It's not a qualified inspector. I never said that. I said a qualified person, and OSHA has a definition of a qualified person. And basically, in the theatrical world, for this application, being a qualified person would be somebody who is certified. And the only certification, the only recognized certification in rigging in this country is ETCP. You know, I don't have it right in front of me. I could dig it up, but OSHA has a definition for a qualified person, which basically says that you have to have some kind of documentation that proves that you have the skill set. You know, that's a paraphrased and much abbreviated definition.
So not definitive by any means.
Well, not definitive. No, but you know, when you look at someone who's got ETCP certification, it certainly puts them above somebody who, well, it doesn't put them above, but it identifies. It's more legal than it is anything else.
Right. I know where you're going with that. Thanks.
Sure. Inger, to answer your question, an engineering degree is all well and good. But I would look at experience. If you were going to do a percentage on it, I would look at the engineering degree being worth 20% and the experience needed to be 80%. Because, you know, you can be the best engineer in the world, but, you know, if you haven't run and had a significant amount of experience with a counterweight system, then you're not going to know about the nuances. You're not going to know when you pull on a line, for example, and you hear that thumping noise, that it's probably a cable wrapped around the spreader bar that we just talked about, because it's not in your, it's not in your experience level. Does that help? I'll take that as a yes. All right, folks. So yeah, it's about 10 of, so we're 20 minutes behind. I'm okay to answer more questions, but if you don't have any, I'm okay to go home too.